Describing motion. You don't always need to see something move to know that motion has taken place. For example, suppose you look out a window and see a squirrel sitting on a bird feeder. 1 minute later, you look out again and see the same squirrel sitting on a fence, period. Although you didn't see the squirrel move from the bird feeder, you know it moved because its position relative to the bird feeder had changed. In order to determine the position of an object, a reference point is needed, and in this case, it's the bird feeder. We knew that motion occurred when the squirrel changed its position relative to the reference point. In PE class, have they ever had you run a lap around a track? An important part of describing motion of an object is to describe how far it has moved, which is distance. If a PE teacher tells you that he or she is standing 50 meters from the starting line, then you know if you run to your PE teacher, you have ran a distance of 50 meters. Remember that a meter is the base unit of length according to the SI units. Longer distances are measured in kilometers, while shorter distances are measured in centimeters. Now, suppose you run 50 meters north towards the PE teacher, and then you turn around and run back to the start line. If you run that entire length, then your total distance ran is 100 meters. However, sometimes you may want to know not only your distance, but also your direction from the reference point, such as the starting line. Displacement is the distance and direction of an object's change of position from the starting point. So in this case, by returning to the start, your displacement would be 0 meters. If you wanted to know the displacement and distance traveled the first time you ran to your PE teacher, then the distance traveled would be 50 meters and the displacement would be 50 meters north. While you were running the track during PE class, besides the distance traveled, you may also want to know how fast you were moving. To do this, you need to know how far you travel in a given amount of time. Speed is the distance an object travels per unit of time. When you are calculating speed, you need to think of distance as the change in position, and speed is the rate at which you change position. Since the SI unit for distance is meter, and the SI unit of time is second, when you divide distance by time, you can determine your speed, which is measured in meters per second. Sometimes you will find it more convenient to express speed in other units, such as kilometers per hour. If you were to put your car in cruise control on a road trip, and the car neither slowed down nor sped up, then the car is traveling at a constant speed. If you are traveling at a constant speed, you can measure your speed over any distance interval. However, speed is generally not constant. Think about riding your bicycle to the store. As you start, your speed increases. As you have to move around people and dodge animals, your speed will increase and slow down. Or if you have to climb a hill, your speed will decrease. And then the opposite would happen if you were flying downhill on bike, then your speed would increase. By the time you reach the store, you check your watch and it took you a total of 15 minutes. How would you express your speed on such an adventure? Average speed describes speed of motion when speed is changing. Your average speed is the total distance traveled divided by the total time of travel. It can be calculated using the relationships among speed, distance, and time. So for the trip to the store we just mentioned, if the total distance was 5 kilometers and the total time it took was 15 minutes, then the average speed would be 5 kilometers divided by 15 minutes, or 0.25 hours. Therefore, your average speed would be 20 kilometers per hour. Instantaneous speed is the speed at a given point in time. A good way to determine instantaneous speed is to use a speedometer. For instance, a speedometer shows how fast a car is going at one point in time or at one instant. Many times, scientists use a distance time graph to show the motion of an object over a period of time. Time is plotted along the horizontal or x-axis of the graph, and the distance traveled is plotted along the vertical or y-axis of the graph. When looking at a graph, the steepness of a line on a graph is the slope of the line. The slope of a line on a distance-time graph equals the speed. The steeper the slope, the faster the speed. Therefore, if the line on the distance-time graph is horizontal, then it has zero slope. This represents an object at rest. Now it's time to show what you know.